So systems engineering is a very difficult and important concept, and it is very easy to learn with example. So I have summarized some examples here. I'll just take some system and then break it down how we could use it as a practice to learn about systems engineering. So systems engineering, as I said, is a very involves designing, integrating, and managing complex systems or their life cycles. That's the basic definition. That is, it involves designing, integrating, managing. So these are three important points. You first design any system, then you have different parts of the system, and then you integrate all the systems to ensure that it works together. Then you manage the complex systems and their whole life cycle. That's what is the basic systems engineering mean. And here in this video you'll learn about certain examples which I'm going to go now. So let's take an example of a home heating system. So you want to design a simple heating system for the home and which keeps your house warm. And this could be any sort of system, right? So let's not go into details. So system components will be basically just for this example, you'll take a thermostat, you'll need a heater and a fan. So thermostat basically senses the temperature in the house, and heater provides the heat when the temperature drops below a certain level, and fan which distributes the heat throughout the house. I mean, the how the technology might be could be varying depending on how your company needs the system or what are the requirements, but this is just an example, so just keep in mind it's an example. So basic components would be just take for example these three. So you have a thermostat which senses the temperature, heater which provides heating, and fan which basically distributes the thing. So these are the system components. So now as we talk about system integration, we have to have, like, the thermostat will communicate with the heater and the fan, because one senses the temperature, and depending on the temperature then the heating starts, and then this heating has to be distributed. So all these three have to communicate with each other. When the thermostat detects the temperature is too low, then it sends a signal to the heater to turn on, and then the fan then distributes the warm air. So this is the basic structure. This is the basic structure of how the system will interact with each other, and that's what you define in system integration. Then once you go to the system management, you will need to ensure that the thermostat is set to the right temperature, and then the heater and the fan are working efficiently, and regular maintenance like changing filters ensures the system work effectively. So here you have three components. So when you are working in any system engineering project, or if you're starting a system engineering project in your college or job or anything, and you're given a new system, then you have to identify what are the systems, basically what are the systems in this whole thing, and then you see how you can integrate that system. So you have you identify the system components, then you see how they communicate with each other, then you see how you manage them. These are the fundamental things. So this will be the first step in any system engineering project which you will be handling. So let's take another example, automobile cruise control. So cruise control in a car is a simple system that basically manages set speed without driver having to press the gas pedal. So this is like cruise control you have in many automobile systems, where the car will run by some sort of automatism. Yeah, so that's what a cruise control is, and it will stop or brake when it sees an obstacle. And mostly these systems are done with radar or any other sensor. So once the radar is sent constantly, the car will send out a radar, and if there's another car in front of it, then this system will get a message and it will slowly slow down or brake. So the system components in this case will be speed sensor, a control unit, and a throttle actuator. So speed sensor basically measures the current speed of the car, that is how much the car is running at what speed, and control unit basically compares the current speed with the desired speed, and desired speed set by the driver. So the driver basically sets a speed, say you travel at 50 or 60, and then the current speed If it is lesser, then it will accelerate. If it is more, then it will brake. So depending on what the user has set, so it will try to maintain that speed. And the throttle actuator is adjust the car's throttle to increase or decrease the speed. So that's the system where the car is speed is increased or decreased depending on the thing. So these are the three main system components. And how you integrate it: speed sensor sends the data to the control unit with constant speed information, and if the car is going too slow, the control unit tells the throttle to open and the throttle slightly and increasing the speed. If the car is too fast, and it reduces the throttle, and maybe if there's also a braking system in this system, then it will apply brakes, sort of thing. So this is how the system will integrate or talk with each other. Then as for system management, how the system must respond quickly, accurately to the maintain the set speed, adjust for hills, wind resistance, and other factors. So these are some of the factors you have to keep in mind if you're designing any system. So these are the factors which could affect the performance of the system. So you have to think about it. So let's take a smart irrigation system. So consider a smart irrigation system designed to water a garden automatically and based on the soil moisture level. And system components in this case would be moisture sensors, which basically detect the moisture level of the soil, and a control unit which basically processes the data from the sensors, and a sprinkler system waters the garden when the moisture levels are too low. So these are the basic system components. And how you design the system integration or will be the moisture sensors send the real-time data to the control unit, and if the soil is too dry, the control activates the sprinklers to water the garden. And the system management will be the system is designed to water the garden efficiently, avoiding overwatering by shutting off once the desired moisture level is reached. So these are the 3 points which you have to basically think about when you are designing any system. Just look for the system components, how the system's components talk with each other, and how you manage the system. So here I'm taking elevator system. This building another simple example system for system engineering. And here the system components could be like a control panel where allows the users to select the floors, and then a motor or pulley system which basically moves the up and down the elevator, and then the safety sensors ensure that the doors are closed before the elevator moves and stop the elevator if something goes wrong. So keep in mind, I'm just taking 3 system components. There will be definitely more system components for in case of elevator or any of the system I am talking about, but just for you to understand how system engineering works, what is system engineering, I'm just making it simplified to say let's take just 3 main components and then talk about it. Yeah, so it's the same here. The system integration will be when the user presses the button, the control panel sends a signal to the motor which moves the elevator to the desired floor, and safety sensors to ensure that the system operates safely. So there are safety sensors to prevent some accidents or something like that. And system management will be the system must ensure that the elevator moves smoothly, stops at the correct floors, and responds to user input. So these are some of the system management things which has to be thought of. Only 3 is mentioned here, but it could be more here. So finally, we look at traffic control light system. A traffic light control system manages the flow of vehicles, which we see every day in any road. And the system components in this case could be traffic lights, that is, which control the vehicle movement, sensors which detect the vehicles and waiting at the intersection, and control unit which decides when to change the lights based on the traffic conditions. So these are the main system components. In here, the system integration will be system sensors send information about the number of vehicles waiting in the intersection to a control unit, and when the change which then changes the traffic lights to manage the traffic flow efficiently. So depending on the traffic, mostly these systems are nowadays are automatic, but just to get an understanding how the systems work together. System management will be the system needs to balance the traffic flow from different directions to ensure that the lights change at the right time. So this could be done with the camera. Maybe a camera is just monitoring the traffic and it sees, okay, so many vehicles are there, and depending on the situation it changes the traffic light. Or there could be a fixed timing, that is within say 5 seconds or 10 seconds that green light has to go on, and that remains constant without adapting. That depends on the system itself. These are the considerations you have to make basically when you are doing a system engineering. So you, whether you use an automatic system or whether you use a fixed timing system, whether you use a camera, which sensors to use, detect like the traffic, and how you monitor, all these are system decisions which you have to make. So as a summary, this video explains you how system engineering involves coordinating different components and working together as one whole. And the key is to integrate these components to so that they function smoothly, efficiently, and ensure that the system meets its overall objective. So a system is basically a combination of different components, and that has to work correctly according to what the requirements are. So that is basically what system engineering is. So hope you got an idea of what system engineering is and different examples. If you have questions, do put it in the Q&A or pass me a comment. I will be more than happy to help. Thanks for selecting the course. Do check my other course like electric vehicle and other courses I have. Some are free, some are paid. Do contact me if you have any requirement for training or coaching. That's one of my core businesses. As far as I'm doing consulting work for software development in embedded systems for automotive and for other domains, and we also have a branch of business where we develop websites and apps depending on the client requirements, and we do consultancy work. So but the core is more related to trainings and coaching. So do feel free to contact me at contact@kmtech.co.uk, and you can visit my website kmtech.co.uk. And I also have another website called queryed.com, which is like a R&D project, which is based on AI software, that is use Java OpenAI APIs to use AI for education. So feel free to just look at the website queryed.com, and thank you for selecting this course.